Now we are going to introduce how amino acids can react to form what is called a peptide bond. The first thing that we need to look at is that we have two carboxylic acid ends and two amino ends with equal opportunity to react to form a peptide bond. If we combine this end of glycine with the amino end of alanine, we are going to form a peptide bond where the first amino acid taken it will be a glycine and the second one will be an alanine, and we have lost one molecule of water. This is actually taking place during a process called translation. We have formed what is called a peptide bond that has the following properties. The first thing is the peptide bond, this amide bond, has a double bond character, and it has to do with the possible resonance structures that will exist between the nitrogen and the carbonyl. So this also can be interpreted as if it is in length similar to what it is a carbon-carbon double bond. So we will say that that is it looks like a single bond, but it has a double bond character. Because it has that character, there is no rotation around that bond, but there will be freedom of rotation around the carbonyl and the carbon nitrogen. Between those two, there is freedom of rotation. So that is the first dipeptide made. So what we'll have is a glycine peptide bond alanine, indicating that the amino end is free on the side of glycine and that the carboxylic acid end is free on the side of the alanine. But the same two amino acids can also combine to form what will be alanine with the free amino end and glycine with the free carboxylic acid end. And that will be written in a different way. Then it will be alanine, peptide bond, glycine. So the last one will be the glycine with the free carboxylic acid end, and alanine will be the first amino acid with the free amino end. So we have two different dipeptides. So we are saying here is we have now two different dipeptides. If I have these amino acids, alanine, glycine, and serine, I can combine them in different ways, and those will be different tripeptides. I can have, let's say, glycine, alanine, serine, that will be one, glycine, serine, alanine is a very different tripeptide, and I can also have an alanine, serine, glycine, and I can build some more, but you get the concept that the last amino acid is the one that has the free carboxylic acid end. Glycine will have the free amino end, and so on. So if we're making a tripeptide, it's because we have opportunity for the free carboxylic acid end to react with another amino acid that has a free amino end. I'm making a tripeptide. I will just call this one here a cysteine. That will be this one. This one will be an alanine, and this one will be a serine. Just making three different examples. So we have now made a tripeptide.